All right, so this is January 2021. We're doing question number 3. It says the diagram below shows two pentagons P and Q drawn on a grid made up of squares. Select the correct word from the list to complete the statement below. All right, and the word I am going with is the word congruent. Now, the word congruent means that the two shapes are exactly the same. So I would say that P is, pentagon P is congruent to pentagon Q. What is the reason? Well, if you look carefully, you'll see that corresponding sides are the same. This is 2 unit, this is 2 unit. 1, 2, 3, 4, 5. This is 5 units. This is also what? 5 units. This is 3 units. This is 3 units. All right. So the lengths of the sides, corresponding sides are the same. What else? It looks as if the angles are the same. Corresponding angles are the same. 90, 90, 90, 90. The angles are the what? Are the same. All right. And if you were to find the other two sides and even the angles, the fact that the lengths of the side, this side and this side are the same length, and this side, sorry, let's put letters on them. If this is X, this is X. This is also X. Sorry, this is X. And if this is Y, this is also Y. The lengths of the sides for for all 5 sides are the same. The lengths are the same. And the angles are also the same. So I would say that the lengths, so to give the reason why we say it's congruent, the lengths and of sides and size of angles are the same. Therefore, the two shapes are congruent. Turning the page. All right, so the diagram below, not drawn to scale, shows pentagon VWX, YZ. In the pentagon, we're told that YZ is parallel to WX, and W and YX is parallel to VW. The angle there is 114, and this other angle is 98 degrees. We're to calculate the value of angle WXY. Angle WXY. All right. So this is a question from angle property. And if I extend these, you should see that you have a situation of parallel lines cut by a transversal. Now, when parallel lines are cut by a transversal, the angles between the parallel line, so here, this is the transversal, and these are the parallel lines. So the angles between the parallel lines, they're called interior angles. So this angle here and this angle here are interior angles. When you have two interior angles on the same side of the transversal, like you have top side and you have the bottom side. So I have two interior angles on the top side of the transversal. Those two angles are supplementary and they are called co-interior angles. So angle WXY is equal to 180 minus 114 degrees. This is what, 66 degrees. And the reason for that is that the two angles are co-interior angles. Now, so you get co-interior angles when parallel lines are cut by a transversal and you have two interior angles on the same side of the transversal. Next, we need to find ZVW. ZVW. So this is the angle we want to find next. The angle is ZVW. All right, let's see how we're going to find that. ZVW. Well, the only thing I can think of now is we just found this and this is 66. Now, these two sides are also parallel. So if this is 66, it means that this angle here is also 114. All right. So I could say that to the examiner that, remember now we're going after this angle here. Let's call it theta. That's the angle we're going after. But I can find this angle and then now I can use a formula, the sum of the interior angles of a pentagon, to find out what is the angle at V equal to. So let's find the angle at W. So I'm just going to simply tell the examiner, let's call this angle alpha, that alpha is equal to 180 minus 66. This is 114 degrees. They are co-interior angles. Now, there's a formula for calculating the sum of an interior angle of a pentagon. The formula is S is equal to, I think it's 180 multiplied by N minus 2 degrees, where N is the number of sides. So the sum of the interior angles is 180 multiplied by 5 minus 2. This is a pentagon, it has 5 sides. So this is equal to 180 multiply by 3. So 180 multiplied by 3, what is this, 540? So the sum of the interior angles of the pentagon is 540. It means if I add up all 5 angles, I'm going to get 540. So if that be the case, it means therefore that theta, which is angle ZVW, would be equal to 540 minus the sum of all of these angles. 114 plus 66 plus 114 plus 98. So there are a total of 5 angles. I know 4 and I want to find the 5th angle. It's simple. Since I know that all 5 must add up to 540, I simply add the 4 and take it away from 540. So this is 180 plus 114 plus 98, and this is 392. So this is 540 minus 392. And if I subtract, my final answer is 148 degrees. My final answer here is 148 degrees. Angle ZVW is 148 degrees. All right, then now that brings us to the C part of the question, which is transformation. So C says the letter A and a point C, which is 6, 6, are shown in the grid below. On the diagram, draw accurately each of the following transformation. The enlargement of the letter A by scale factor 2, about 6, 6 as the center. All right, so we need the transformation. Guys, this is how I tell my students to the transformation, enlargement. We're going to use the fact that whatever is the distance, so I'm going to use these 3 points, this point here, and this point here. I'm going to use those 3 points. Whatever is the distance from the center, so this is the center, this is the center. Whatever is the distance from the center to the object, to get to the image, I'm going to double that distance. So if the scale factor is 2, to get to the image, I'm going to double the distance. So we're saying the scale factor is 2. So we're going to double the distance. Now, to get from A, from the center to the top point, I have to go 2 units to the left and 2 units down. If I double that distance, it means I must go 4 units to the left, 1, 2, 3, 4, and 4 units down. 1, 2, 3, 4. This is going to be the new top of the letter A. Remember, I'm enlarging the letter A by a scale factor of 2, and the center of the enlargement is 6, 6. Now, what did I do? I'm using the fact that whatever is the distance from the center to the object to get to the image, with a scale factor of 2, I must double the distance. So I'm going to now this point here on the left, I have to go 1 left and 1, 2, 3, 4 down. So 1 left, 4 down. If I double that distance, it's 2 left and what? 8 down. So I go 1, 2 left, 1, 2, 3, 4, 5, 6, 7, 8. This is the new position of that point on the right. And now from the center to the one on the left, it's 1, 2, 3, 1, 2, 3, 4. That's 3 left, 4 down. 1, 2, 3, 1, 2, 3, 4. If I double that distance, it becomes what? 6 left and 8 down. From the center, 1, 2, 3, 4, 5, 6 left. 1, 2, 3, 4, 5, 6, 7, 8 down. That's the new position. All right. And all I have to do now is to connect my points then. And I connect these points. I form about my letter A. And then now in the middle, I just do this. All right. So that is my enlargement of the point A with a scale factor of what? 2, and the center of the enlargement is 6, 6. Next, this says the translation of A using the translation vector minus 3, 2. Minus 3, 2. Now, minus 3, 2 is telling me how to move the shape. The top value deals with horizontal movement, and the bottom value deals with vertical movement. Now, the top value being negative is telling me I must move the shape, the entire shape, 3 units to the left, and the bottom value is positive 2, so I must move the shape 2 units up. So I'm going to move the letter A 3 units to the left and 2 units up. I'm going to move it 1 vertex at a time. The top one, 1, 2, 3 units to the left, 1, 2 up. This is the new position of the top of A. Then this one, 3 units to the left, that end point to the right, 1, 2, 3, and 2 units up, 1, 2. New position here. The one on the left, 3 to the left, 1, 2, 3, 2 up, 1, 2. This is the new position of A if A is translated 3 units to the left and 2 units up. That's the new position of A if A is translated 3 units to the left and 3 units to the left and 2 units up. So those are the images of the letter A after an enlargement and after a translation.